Okay, so Sophie, did you say there was one you wanted me to go back and look at?
No, just.
Oh, by the way, that last big problem we did, number 30,
Yeah.
where we had to find the whole big derivative and then plug in the things for t and come up with the two different lines, you said that was on last year's final.
Oh.
So we tore through it.
Get pumped about that.
No, I'm gonna die.
We're all gonna die sometime.
It's okay.
I should just schedule the math placement
Maybe
test
you
right
should
now.
Right now, yeah. Which one, Sophie, am I doing?
Oh, no, if we have
So
any time, I
I'm
need
gonna die.
Okay, so you were on the back page, right?
That's a problem.
We should have a quiz tomorrow, but everybody's moving on.
Except
Did
me.
anybody try page 169, 1359?
Yeah, I did.
Okay, did you do okay with those? Okay. So you move on to 13.
They're all in the back, Mr. Aldridge.
Huh?
They're all in the back.
What's all in the back?
All those numbers.
Because they're all odd?
Yeah. That's why they all got them. They all looked at the
I think
back.
that's true.
Yeah, it is.
All right, so 13 gets us back into implicit differentiation. Yes, it is raining. So we haven't done this for a while. That's where you have to do the y prime thing, all right?
Who did?
Because the x's and the y's are mixed up together. So I'm going to take the derivative of e to the x over y.
Then you have to get y prime by itself.
Then I have to solve for y prime, yeah. So the derivative of e to the xy, or x over y, is e to the x over y, right?
Yeah.
And then I have to take the derivative of this, and now I have to do the quotient rule.
Son of a mother's gun.
So I have to go low.
Can you bring y
What?
up to -1?
Can I do what?
Bring y up like this. Have y
Oh,
be
sure.
-1.
So you want to rewrite it as e to the you have to go power or product rule then. Maybe that'll be better. I'm wondering if we shouldn't just take the natural log of both sides and get rid of that e right off the bat, but I don't know if that would help.
Let's do that.
But then you'd have a natural log on the
That's
other
what's going
side.
after the back.
Well,
E it,
taking
you
the
don't have that
natural.
log.
What?
That wasn't smart, was it?
Let's go with this and see where it takes us, and then we'll go from there.
Where'd it go?
Okay? So now I need to take the derivative of xy to the -1, right? So it's the first one times the derivative of the second. So what's the derivative of y to the -1? Negative y to the -2, and then since this is times y prime. Okay? So that's a prime there, not a 1. So first one times the derivative of the second, plus the second one times the derivative of the first, which is just going to be 1, right?
Correct.
Correct. Over.
Sophie, you seem to still
I'm confused. Oh, okay, no, I got it.
We good? Okay, and then that equals the derivative of this side. So the derivative of 5x minus y is?
X minus y.
5 minus y prime. Okay. And then now I have to solve this for y prime. Okay? So let's do some distributing.
Okay.
So if I can combine all these to, I'm going to go back to positive exponents. So I'm going to have an xy prime on the top. It's negative and it's over y squared, right? Plus y to the -1, so that's plus 1 over y equals 5 minus y prime. Ah, this is gross. Why do math people hate the world?
They need to have a suicide.
Gosh.
Too soon.
Okay, now what? I guess I need to distribute the e to the x over y also.
So you get common.
Come on.
I could get, I was thinking about that. Should we just get a common denominator, make it a little easier, maybe?
You know, this math problem is just making me.
I need a situation for possibilities.
I'm not ready.
Yeah, financial fitness. Okay, so I just changed this into y over y squared, right? And then that's going to give you negative xy prime plus y over y squared. So that didn't really help us that much. Now I still have to distribute the e to the x over y, so that's going to be negative e to the x over y times x y prime plus e to the x over y over y squared equals 5 minus y prime. Okay? Now what?
Well,
You gotta go like,
Yeah, so what do I do, next?
add all that and subtract the one, or add one.
Say again?
We're just like switch the side.
Switch the sides?
Not right side.
What?
Prep, bro.
Okay, what do you want me to do now?
I don't think you can do it. It's not all negative, it's just.
Okay. Anybody know? Multiply by y squared.
Now, my next guess.
So negative e to the x over y, that's supposed to be x over y there, times xy prime plus e to the x over y equals 5y squared minus y squared y prime. Awesome. Now we're almost done.
Hold on. What was happening?
zero point five y squared equals y squared.
Nope, I just multiplied by y squared.
Add
Add the one.
Yep, we're making all the y primes now on the left and all the non-y primes on the right. So negative e to the x over y times x y prime. This moves over there as plus y squared y prime equals 5y squared minus e to the x over y like that.
And then factor out like prime.
Factor out the y prime and divide, so my final answer is going to be this stuff over negative e to the x over y x plus y squared. Woof! If anybody tries to cancel those y squareds or cancel those e to the x over y's,
I'm learning.
You just cross them.
4 years.
yeah, exactly, you don't learn any math. Find your algebra teacher or something
You
down.
really hosed us there, though.
You are.
I think you messed up.
I'm yours. Did I have all of you in algebra?
Yep. You had me since my 8th grade year. Woo-hoo-hoo.
Really?
Yeah.
5 years?
Yeah.
You had algebra with me, but then did you go to Mr. Helvey for the rest? How about you? Same? You?
Algebra and
Oh,
geometry and then.
I was gone for geometry.
I don't think I know me too.
So kind of
Yeah,
mixed it up.
5 years.
You guys are the only 5-year letter winners?
Oh, yeah.
I was with you for 4 point, like, quarter.
Not good enough.
I went to triples.
Was that advanced algebra year? Did we
That was-
split that?
Yeah,
No, I
I was
think
in that
that's-
class, which is a huge class.
Wait.
All right, did anybody do the page 162 ones?
Oh, that's
Yeah,
one I
I
had a
remember
question
Sean
on.
Okay, which one?
Trouble,
Let
so
me
you can learn anything.
Didn't do it. I saw 56 and I just, 47,
Oh, sorry, got it.
Wasn't that bad, but definitely, it wasn't trying to simplify it at the end.
Okay, that's okay, you don't have to.
Oh, wait, I wasn't sure how to get the second derivative.
So, you want me to take a look at 47?
Yeah, why don't I give you the first derivative and then you can help me find the second
That
derivative.
sounds like a nifty plan, so.
You already did that?
yeah.
Okay, what's the first derivative?
X over the square root of x squared plus 1.
Okay. All right, so this is going to be the quotient rule then to get the second derivative.
Put up top.
You want to just put it at the top and go product rule? So we're going to rewrite this as x times x squared plus 1 to the negative 1/2.
Hey, I was just kidding.
I don't care, either way.
She said it screwed up her plan.
Whatever, Ross.
What do you want to do, so?
That's fine.
That's fine?
That's probably gonna be easier to get.
Mostly.
No one likes the quotient rule.
Nobody really likes the quotient rule now.
Ruthie does.
Ruthie
That
does?
should be nice
Because the square root on the bottom, yeah, I was kind of noticing that too, because when you go over the square of what's below, then that's going to cancel your square root. But but whatever. Yeah, it'll work out the same anyway, because it's math. So it's the first one times the derivative of the second. So the derivative of x squared plus 1 to the negative 1/2 is?
Negative half times x squared plus 1 to the negative 3/2
Times
2x.
2x, okay? First one times the derivative of the second plus the second one times the derivative of the first, right? And honestly, before you guys came in and I was chatting with the guy yesterday, you could leave it like that.
Yeah, you didn't hear it.
No,
Wait, what?
like that.
No,
Let's
Right.
be ambitious.
He said, that's fine, we can simplify it a little bit, but he said the way, because they enter their homework answers online, and the computer, if you enter this in right here, what it does is it picks like 10 random values for x, plugs those in, and then compares it to the answers that they have for theirs, and if they're the same, it's good. So he said that if the answer is 1 over x, and you type in x over x squared, you'll take it. Yeah. Too computery for you. Well, welcome to the 21st century, Cody. It's time. All right, Sophie said, let's get whatever she said. She said something that made me think we should try this. So, x times, but some people want to do. So x times x is x squared. And I solve this negative. So it's negative x squared over x squared plus 1 to the 3/2 plus 1 over x squared plus 1 to the 1, right? Okay, and if you wanted to get a common denominator, well, this is to the 3/2 and that's to the 1/2, so I have to get both to the 3/2, right?
You can just leave it like that.
Okay, let's just leave it like that. All right, any other ones from the book, from that first, from page 162?
56.
What's this?
I've done 53 yet.
Dale.
Have you tried it though?
Tara always does this.
Have I tried 56?
No, Cody's said something about 53, but have you tried 53 and you?
No, I
Oh,
don't think I
okay.
just need like a minute to do it.
That's fine.
Oh, 53 is not that
56 is gross.
Nasty.
bad.
Austin.
It is, Sophie, have you seen it?
Yes.
Turkey.
Ah.
Oh, yeah. I just know it.
Okay, 56, the curve, the absolute value of x over the square root of 2 minus x squared is called a bullet nose curve. Find an equation of the tangent line of this curve at the point 1, comma 1. Not as bad as you might think, because if we are looking at the point 1, comma 1, we only have to look at the positive side of the absolute value function. So I can really rewrite this as x over the square root of 2 minus x squared. Okay? Then I have to take the derivative of that, and I'm going to do a quotient rule. I don't care what you guys say. Okay, so low B high minus high B low, so that's going to be 1/2 times 2 minus x squared
Big old one. It's so loud.
over the square of what's below. Okay, so that's my derivative.
That was good.
Yeah, that looks nice and delicious. So these cancel. And then I need to plug in 1, right? And I want the slope at the point 1, 1.
So that's one.
So yes, this will be 1 minus the 1/2 and the 2 cancel. This is also going to be 1, even though it's to the negative 1/2. It's still 1 because it's 1 over 1, which is 1. This is 1, and this is 1, and this is a negative, and that's a negative. And so it's going to be 1 plus 1 over 1, which is 2. Okay? So my equation is going to be y minus 1 equals 2 times x minus 1, or since we're going to graph this, y equals 2x, that's minus 2 plus 1 is minus 1. Okay? Not bad at all. So then they want us to graph that so that we can see. All right, so original equation is opposite value of x.
Tangent line.
What? What's the tangent line?
Is this?
What's what we're gonna look at here. So, over the square root of 2 minus x squared.
What's it?
And then what was the equation of the tangent line?
6, 6,
2x minus 1.
2x minus 1.
65.
So there's the bullet nose curve. Then
Got
there's the
you.
tangent line. Okay? And you can see that it's tangent to the graph at about 1 1.
Why is it called a bullet nose curve?
Really? Did you not look at the graph? I
Have
don't
you ever
know.
seen a bullet?
Yeah.
Look at the graph. It looks like a bullet.
No one's done it.
Zoom in a little bit. See how the nose of it kind of has that bullet shape?
All you gotta do is draw a smiley face into the line.
It's not a smiley face.
No.
Bullet
No,
nose.
no, the bullet part has a smiley face on it.
Oh. Yeah. That chases them.
I don't think that's a smiley face. Just draw it. Oh, you can't draw that. Probably didn't figure out something quick.
Yeah, that's your assignment for tonight.
What?
Okay, anything else from page
That would
162?
suck. That would be terrible. isn't it?
No, I wouldn't do that.
What's the derivative?
Yeah,
It's
well,
so
you know how
hard.
many teeth there are?
What?
What's the derivative of sine squared of x with 2 cosine it?
No, it's 2 sine of x, cosine of x. You do the exponent first, and then you do the thing inside of it. Okay, anything else from page 162?
I didn't finish.
Okay, well, I'll let you guys work on those, and then if you have questions, you can let me know. Let's take a look at 15, 16, and 17. Has anybody of the gals that are actually doing their homework, have you looked up at all online the answers?
I was going to the
So
other night,
nobody
but my
really did?
internet wasn't.
So I did all that work for nothing?
You put them all online?
I've done it before, it was mostly.
I went to all online.
The nice thing about the ones that are online is it's not just the answer,
It's the steps.
it's the
Yeah.
steps to get the answer.
That is
So,
very good.
yeah. But nobody cares.
No, I seriously was going to look, but we have Wi-Fi and it was screwing up. I think my mom was like looking online, and I don't know what she could possibly be looking at, like the news.
You got a virus somehow?
I'm like.
For what
"Really,
value of
Mom? Why
R?
do you watch the news right
Right now.
now?"
For what value of r does the function y equals e to the rx satisfy the equation y prime or y double prime
Dude, sorry. I did it.
All right, so we're just going to plug this in and then solve it. Okay?
All right.
But we need to know what y prime is and we need to know what y double prime is.
So I gotta take.
Double derivatives. Is R a constant?
Yes, sir.
Nice.
So what's y prime?
It's actually R. Is it R? No. There we go.
Okay, r e to the rx. What's y double prime?
Was it 2R?
R squared e to the rx. So that gives us a little equation.
Is it R? Oh,
Well, Mr. Aldrich, what are you doing just in general?
What am I doing just in general?
we took the double derivative.
Yeah.
And first we took the regular, then put it into that equation up there. Now we're going to solve for
Yeah, I don't know, for r?
R.
Because it says, for what value of
How
r?
did you get all that and I
No, we can
didn't?
just leave that like that, right?
No, it's all for x.
I don't know.
Maybe because you were playing with my book.
For what values is r?
Okay.
So does that mean I have to solve for r?
Satisfy the.
Dude, I read
what is-
this.
What does that mean? Satisfy the equation.
Make it true.
Oh.
Listen to this, okay?
Okay.
I read this fact online, and
What website?
it was on Twitter. And it said, if you study while chewing gum, and you take a test while chewing gum of the same flavor, you're gonna remember more.
No way.
That's so cool.
No way. That's
Okay,
big.
so wait, what?
I'm gonna start doing that. That's big.
You just go to say,
trying to solve for X?
I'm trying to solve for R, you can solve for whatever you want.
We'll solve for 2.
Okay,
2 equals.
yeah,
At
you
least we're entertaining.
Hey, it's always
you're
good.
always a good time. You can factor out an e to the rx, and then that's really handy because now we have two equations. We have e to the rx equals 0, which you know from our conversation yesterday. Will that ever happen?
No.
No, because e is a positive number.
What
You
about
can never
R?
take a positive number and raise it to any power and get 0, okay? So this is out, nobody cares. Sorry, e to the rx,
Sorry.
you lose. So now we just need to solve this for r, and I'm hoping this is gonna factor. It does!
Who did?
Oh my god, I did something right.
Oh
I'm 3, dude.
my goodness. So the values for r that will make that equation be true are -5 and 3.
R equals -5.
Julia.
I actually kind of did that one.
Yeah, I was good when somebody said, how come you understand this? If I were you, would
You
think
know, I
that's a
feel
little bit of an
bad.
insult.
That's
Austin,
5.
Austin's
Okay.
secretly smart.
He's not secretly smart. Both of them, well, all the boys in the class are smart.
Oh!
I was gonna say both the boys
Yeah, what
are
does that
smart.
mean?
All right, 16. Cody said on number 13, she needed a situation. So here's the situation. It's the motion of a spring that is subject to a frictional force or a dampening force, such as a shock absorber in a car. It's often modeled by the product of an exponential function and a sine or cosine function. So if you're designing shocks for cars, you need
Listen
to know
up.
calculus. Suppose the equation of motion of a point on such a spring is...
This is cool.
Watching on the screen.
Yeah.
It's better resolution on the screen.
I saw Garrett Bernal the other day. He was dancing on the side of the...
I saw it too.
like Liberty Mutual. I don't know. What is it?
Who was?
Garrett Bernal just in a
He's
working
working for the thing?
Yeah,
Statue
Aberdeen.
of Liberty just dancing away. I was like, who is that guy? And I
Does he
said,
have
oh,
a
it's
beard?
Garrett. Oh my gosh.
That is what he got out of his Montesano education.
Yeah.
So he's not going to school.
He posted on Facebook that he uses Project Medium the other day though. I think that's why.
To get the job, maybe, to hold the
Maybe,
sign and
yeah.
dance?
What you said?
I was in drama
I
club.
looked at the comments.
Give me a job.
You did this as well.
Well, that's not using your project.
But it's, they're in there.
No, but you could have called the school too. So he's going into the military, but he's not smart enough or something.
I guess it's harder to get in the military after you graduate because they like take the high school students before they take the other
Really?
And it takes like months to get in. What's his name? James McCullough.
Oh, yeah.
He's been waiting like 2 years to get in and he's getting deployed to, well,
Right. Anyway, so we're designing shock
Yeah.
absorbers. So here's the position equation. What do we have to do to find the velocity equation? Take the derivative. So the derivative of a position equation is the velocity equation. So I'm going to have to go product rule here. Okay? So first one, 4e to the negative 1.5t times the derivative of the second one. Do it right.
Cosine.
No, do it right.
2
2 pi.
Oh, I'm sorry.
It's okay, we forgive you. You are forever forgiven, Sophie,
Oh my
because of what
God.
you did yesterday. That was like top 10
Walks right
all-time
in.
moments. Walks right up in her little toe shoes. Hi, my name is Sophie Marshall, and I'm going to be a husky next year. You didn't even say you're going to the youth. You said I'm going to be a husky.
You should have
And then he
said,
said,
I'm
"Where-
the best
where's
cross
your
country I've
W
ever seen."
gear?
What?
He said, where's your W gear?
Mr. Aldrich is like, tell him you're majoring in math.
Yeah.
I'm like, but I'm not.
Okay, so
No
that's
way.
the first one times the derivative of the second. Now we have to go plus the second times the derivative of the first. And so you all know that's going to be negative 6 e to the negative 1.5. Could we simplify? Yes. Are we going to? No. Are we going to graph both the position and velocity functions from 0 to 2? No.
So part A was just finding the derivative.
Yep, because the velocity function is the derivative of the position function.
After 2 seconds.
Yeah, because this is t, there's a variable. Garrett Van Noy, hold the sign.
He's not just holding, he's dressed
Oh,
up.
he's-
dancing,
that makes me
pumping up,
happy.
it's all crazy. Awesome. Hold on.
Hold it.
5, what is that little? Is that a pi? No. Sine, that's what it is.
How does that look like a pie?
It looks like 5.
This right here?
Yeah.
Yeah, that looks like a line to you.
5.
I got you.
He said odd. That's how much.
I did say 5 first, but I realized I was saying. Yeah, okay.
Okay, then last one.
Never mind, it's long.
If you stop bringing down, I'd be completely happy.
Or it can rain really hard. And thunder.
Yeah, we just need thunder in that camp.
We just go like
Okay,
this. You
so we're
imagine
gonna-
lightning?
We're gonna, I'll tell you a story about that. I'll tell you a story about that as soon as we finish this problem. Okay, we need to find g prime of 1. So I have to take the derivative of g, right? And so this is, Kyle and Nico, the function written in, it's the chain rule, but it's in composition of function form. So it's the same thing that we've done before. You take the derivative of the outside function and leave the inside alone, right? And then you multiply it by the derivative of what's inside. So it's the same rule, just written in a different way. If I want to find g prime of 1, I have to plug 1 in for all of my x's. And then figure that stuff out.
When X is 1.
So what is
X
f of
equals
1? 2. Okay? And then I'm going to multiply that by f prime of 1. Okay? Now this table that they give us only gives us the values and not the derivatives. And that's why it says use the table to estimate. So if I'm going to estimate the value of f prime of 2, what I'm going to do is I'm going to look at the values right around it, and I'm going to basically do the slope thingy from there. So f prime of 2 is going to equal, for me, it's going to equal 4.4 minus 2.4 over 2.5 minus 1.5. Okay? Because I'm looking at, I'm taking the slope of that curve at 2 points very close to the point that I'm interested in. Does that kind of make sense? So I'm basically using the slope of the secant right around 2 to figure out what the slope, or estimate what the slope would be at 2. So 4.4 minus 2.4 is 2. That's 1, so that's going to equal 2, approximately. Then same thing for f prime of 1. I'm going to look at the y values on either side of 1. I want to look at the y values because it's y2 minus y1 over x2 minus x1. So I'm going to use 2.4 and 1.8. Okay?
Over 1.5 minus.
Then that's going to be 0.6.